Bismillahirrahmanirrahim. Assalamu alaikum students. It is Mubashir Riaz. And today we are going to start our next chapter, deformation of solids. And our first topic is elasticity and Hooke's law. So in this unit we will discuss about the structure of solids, their elasticity, their plasticity, and the relation between the force and extension produced in the material. So first of all, what is meant by deformation of solids? Solids की deformation से क्या मुराद है? So here, solids change their shape under the action of applied forces. And this change may be larger or smaller. This change may be large in case of springs or hardly noticeable in some structures such as buildings. कि कुछ ऐसे substances हैं जिनमें ये जो change under the action of applied force occur होगी वो बहुत कम होगी और ऐसे substances भी हैं जहां पर change बहुत ज़्यादा note की जा सकती है. So this change which occurs under the action of some applied force is called deformation of solids. So a change in shape due to the application of force is known as deformation. For example, if we apply a force on a spring, so initially there is a spring whose length is L in its equilibrium position. So when we apply some force to compress the spring, then its length becomes short, and this is the new length of the spring under the action of an applied force, which is also called a compressive force. So in the action of, under the action of this compressive force, the length of spring reduces. Similarly, there is another example of deformation when we compress a ball, when we squeeze a ball. So we apply some force on that ball. So under the action of that force, its volume changes. So this kind of change is called deformation, and sometimes this deformation is very large and sometimes this deformation is very small. So it depends upon the structure of that substance. So in this unit we will discuss about the deformation of solids. So here are two types of forces. So whenever we have to produce a change in the shape of a spring, a pair of force is needed. And that pair of force is in the form of compressive force and a tensile force. So there are two types of forces, compressive forces and number two, tensile forces. Sometimes we apply compressive forces and sometimes we observe the tensile forces. For example, tensile forces here causes an object to be stretched. कि जब tensile forces exert हो रही होंगी, इसका मतलब कि इससे ऑब्जेक्ट की लेंथ में इजाफा होगा. It causes an object to be stretched. So this deformation is called tensile deformation. For example, there is a wire whose length is represented by L naught, whose area of cross section is represented by A naught. This is initial area of cross section or original area of cross section and the original length of that piece of wire. So when we apply tensile forces on this piece of wire, this would be the final shape or change in that wire. इसमें आप note कर सकते हैं कि under the action of these tensile forces, the length of this wire increases. उस वायर की जो लेंथ है वो एक्चुअल लेंथ से ग्रेटर हो जाएगी. It will increase under the action of tensile forces. So tensile forces causes an object to be stretched, whereas compressive forces causes an object to be squashed or compressed. So that's why it is called compressive deformation. The deformation occurs under the action of compressive forces is called compressive deformation. For example, there is a piece of wire or there is a cylinder, small cylinder whose original length is represented by L naught. This is the original length of this piece of wire. Under the action of these compressive forces, its length reduces. Its length reduces, and the change in length is represented by delta L. Here delta L is the change in length. So this kind of deformation is called compressive deformation, which occurs under the action of compressive forces. And the above kind of deformation is called tensile deformation, which occurs under the action of tensile forces. So these are two kind of forces. Under the action of these forces, this deformation occurs. Now there is another example. When a wire is bent, some parts of the wire, some parts become longer and they are in tension, while other parts become shorter and are in compression. कि जब आप एक वायर को बेंड करते हैं तो उस बेंडिंग के दौरान आप नोट करेंगे कि उसी एक वायर के कुछ ऐसे पार्ट्स होंगे जो पहले से जिनकी लेंथ बढ़ जाएगी एंड दे आर इन टेंशन, और कुछ ऐसे पार्ट्स नोट करने को मिलेंगे जो पहले से शॉर्ट लेंथ में हो जाएंगे एंड दे आर इन compression like this wire. So this is a piece of wire, and when it bent, so after bending the wire you can observe the compression inside. यहाँ आप compression note करेंगे and the extension is produced in the outermost side. यहाँ compression extension note की जा सकती है, यहाँ compression note की जाएगी. So in the same wire this compression and tension occurs. So this tension occurs under the action of tensile forces, and this compression occurs under the action of compressive forces. So compressive forces as well as tensile forces, they are required to produce deformation in the substance. So there is an information, if thicker the wire, the greater the compression. कि अगर वायर थिक होगी तो compression greater होगा, और अगर वायर thin होगी then compression would be smaller. So thicker the wire, the greater would be the compression that is produced in the wire. Next, there is a statement which describe the relationship between the applied force and the extension produced in the substances under the action of tensile forces. So according to statement, extension produced in a spring is directly proportional to the applied force. कि एक स्प्रिंग में प्रोड्यूस होने वाली एक्सटेंशन अप्लाइड फोर्स के डायरेक्टली प्रोपोर्शनल होगी. सो लेट वी सपोज देयर इज अ स्प्रिंग in its equilibrium position, and here O or 0 is its equilibrium position. And when we add some load to the spring, आप इसके बॉटम में कुछ लोड ऐड करते हैं, कुछ फोर्स अप्लाई करते हैं, इससे इस स्प्रिंग में एक्सटेंशन प्रोड्यूस होगी. So this extension produced is represented by X. Here X is the extension produced in the spring. So according to Hooke's law, this extension produced depends upon the applied force. But there is a very important point that this relation, which is extension directly proportional to applied force, occurs within a specific limit called the elastic limit. So in the elastic limit, within the elastic limit, this extension produced is directly proportional to applied force. कि आप जितनी ज़्यादा force apply करेंगे, extension भी उतनी ही ज़्यादा note करने को मिलेगी. If applied force is smaller, then extension produced in the spring is also smaller. So extension produced in the spring is directly proportional to applied force. To remove this proportionality sign, we can write this equation F is equal to Kx, where K is called spring constant, or it is also called the stiffness of the spring. K is called spring constant, or it is also called stiffness of the spring. This spring constant or force constant, it is also known as force constant. So spring constant or force constant can be defined as the ratio of applied force to extension which is produced in spring. So this ratio is called spring constant, or we can define the force per unit extension. So this force per unit extension is also known as spring constant. So we can write K equal to F over X, where F is the applied force, X is the extension produced in the spring. Its unit is Newton per meter. Newton per meter. For force there is Newton, for extension there is meter. The larger the value of K means the harder the spring. एक स्प्रिंग जितना हार्ड होगा उतनी ही value of K greater होगी. So we can say that the value of K depends upon the nature of material of the spring used. कि स्प्रिंग किस मटेरियल का डिजाइन किया हुआ है उसकी नेचर पे डिपेंड करेगा. And it also depends upon the units used to measure this force per unit extension. So the larger the value of K means the harder the spring. This value of K can also be determined by using the force extension graph. So with the help of force extension graph, we can also determine the value of K for a certain material. So this is the force extension graph, where extension is along x-axis and applied force is along y-axis. And initially this graph is a straight line from point O to point X. This graph is a straight line, and then X to Y, it changes to a curved line. So from O to X, or from origin to this point X, this straight line proportionality show that this force and extension, they are directly proportional to each other. So it is also called the limit of proportionality. इसको हम यहाँ limit of proportionality भी कह सकते हैं. So this limit of proportionality actually defines the Hooke's law. So to determine the value of K, we have to determine the gradient of force extension graph. So with the help of gradient of force extension graph, we can determine the value of force constant or spring constant. So here K is equal to F over X, where F is actually the change in y-axis, and X is actually the change in x-axis, which is also known as extension. So this gradient is also equal to spring constant. So with the help of this force extension graph, we can also compare the value of K for different materials. जैसा कि यहाँ ये इस example में है. So there are two straight lines, A and B, for two different substances, between load and extension, between force and extension. So by comparing both lines, we can describe that the material B, in material B, there is a large extension, but the applied force is smaller. In material A, there is a less extension, but there is a large force. So we can say that material A is harder than the material B. So there is a large force required to produce extension in material A as compared to extension produced in material B. So with the help of this load extension graph, we can describe the value of K and the stiffness of the material. Now, when two or more springs are connected in parallel, their spring constant increases, but extension decreases. कि जब दो या दो से ज्यादा स्प्रिंग्स को एक दूसरे के पैरेलल कनेक्ट कर देंगे तो इनके स्प्रिंग कांस्टेंट की वैल्यू यानी K की वैल्यू इंक्रीज हो जाएगी, लेकिन जो एक्सटेंशन प्रोड्यूस होगा दैट विल डिक्रीज. फॉर एग्जांपल, देयर आर टू स्प्रिंग्स having spring constant K as well as K. So both springs have same spring constant and they are connected parallel to each other, and then a mass is suspended with these springs. So in such case, the value of K increases, which is also called the equivalent value. So equivalent value of K will increase in case of parallel, but the extension produced will decrease. So value of K is equal to K plus K becomes equal to 2 times of K. यानी ये increase हो जाएगी. But when two or more springs are connected in series, then spring constant decreases, but extension increases. यानी अगर सीरीज में कनेक्ट किया जाए तो स्प्रिंग कांस्टेंट डिक्रीज हो जाएगा, लेकिन एक्सटेंशन इंक्रीज हो जाती है. So this is an example when two springs are connected in series having same spring constant equal to K. So their equivalent spring constant can be determined by using this expression 1 over K equivalent is equal to 1 over K plus 1 over K. So it can be determined by taking the sum of the inverse of the spring constant 1 by K plus 1 by K is equal to 1 over K equivalent. So with the help of this mathematical form, we can determine the value of equivalent spring constant when number of springs are connected in series. So by comparing both equations, we can compare the value of K in both cases. So here K becomes double, बट हियर के 1 ओवर के. यहाँ आपने याद रखना है कि जो के इक्विवेलेंट की वैल्यू होगी वो हर स्प्रिंग कांस्टेंट की वैल्यू से भी कम होगी. सपोज इट इज 1, इट इज आल्सो 1, बट दिस के इक्विवेलेंट वुड बी लेस देन 1. ये उस सबसे जो स्मॉल स्प्रिंग कांस्टेंट है उससे भी कम हो जाएगी. सो 1 ओवर के इक्विवेलेंट इज इक्वल टू 1 ओवर के प्लस 1 ओवर के. So now what is meant by elasticity? Elasticity is the property of a material due to which it restore its original dimensions after removing the applied force. Is called elasticity. कि ये मटेरियल का वो बिहेवियर है जिसमें अगर आप एक्सटर्नल फोर्स को रिमूव करते हैं तो उस सब्सटेंस के अंदर पैदा होने वाली तमाम जो डिफॉर्मेशंस हैं वो रीस्टोर की जा सकती हैं, रीट्रेस की जा सकती हैं. सो दिस टाइप ऑफ प्रॉपर्टी और बिहेवियर ऑफ द मटेरियल इज कॉल्ड इलास्टिसिटी. यानी यहाँ तक जो भी चेंजेस होंगी वो एक टेम्पररी चेंज कंसीडर की जाएगी. जैसे ही आप एक्सटर्नल फोर्स को हटाएंगे तो वो सिस्टम अपनी ओरिजिनल डायमेंशंस रीगेन कर लेगा. जैसे एक स्प्रिंग पे आप फोर्स अप्लाई करते हो उसमें एक्सटेंशन प्रोड्यूस होगी, और जैसे ही आप फोर्स को हटाएंगे तो वो एक्सटेंशन खत्म हो जाएगी और वो स्प्रिंग अपनी नॉर्मल जो डायमेंशंस हैं वो रीगेन रीस्टोर कर लेता है. सो दिस इज ड्यू टू दिस प्रॉपर्टी इलास्टिसिटी. एंड समटाइम्स वी अप्लाई फोर्स बट सिस्टम is not able to restore or retrace its original dimension. Then this property is called plasticity. कि अगर सिस्टम अपनी ओरिजिनल डायमेंशंस रीस्टोर नहीं कर पाता तो उसको प्लास्टिसिटी कहेंगे. बट इफ इट रीस्टोर इट्स ओरिजिनल डायमेंशंस देन इट इज इलास्टिसिटी. There is an elastic limit for every substance, and it is the maximum force that a material can withstand without any permanent change, and it is called its elastic limit. कि ये एक मैक्सिमम फोर्स होगी जहां तक एक मटेरियल परमानेंट चेंज लाए बगैर उस फोर्स को बेयर करता है, उसके साथ विथस्टैंड होता है. तो इस फोर्स को इलास्टिक लिमिट बोलेंगे. जैसे आपके पास ये स्ट्रेस स्ट्रेन कर्व और फोर्स एक्सटेंशन ग्राफ इज गिवन. सो इन दिस फोर्स एक्सटेंशन ग्राफ अप टू पॉइंट x देयर इज प्रोपोर्शनल लिमिट. यहाँ तक जो फोर्स और एक्सटेंशन है दे आर डायरेक्टली प्रोपोर्शनल टू ईच अदर, एंड अप टू फ्रॉम x टू y दिस y इज द इलास्टिक लिमिट. कि यहाँ तक जो भी चेंज आएगी उस सब्सटेंस में वो टेम्पररी चेंज होगी, आर्जी तौर पर होगी. सो इफ वी क्रॉस दिस पॉइंट y देन मटेरियल बिकम परमानेंटली चेंज. तो इसमें जो पॉइंट y तक स्ट्रेस है, जो पॉइंट y तक अप्लाइड फोर्स है, दिस इज द इलास्टिक लिमिट. एंड विद इन इलास्टिक लिमिट द फोर्स and extension are directly proportional to each other. Thank you.